He used to eat breakfast at 7, every morning for 30 years. Coffee, 2 eggs, a slice of toast. 7 o'clock. Before the news, before the phone, before anything else. It was the most consistent thing in his life. Then he retired. And without the alarm, without the commute, without the rhythm of work pulling him out of bed, the 7 o'clock breakfast quietly became 8, then 8:30. Then, on days when there was nowhere to be, closer to 10. His name is David. He's 67. He didn't think anything of it. Why would he? He was sleeping better, eating when he was hungry, living at a pace that felt earned after 4 decades of early mornings. What he didn't know, what almost nobody tells you when you retire, is that the timing of that first meal is one of the most powerful signals your body uses to set every other biological clock in your system. And after 60, those clocks are already running differently than they used to. I'm Dr. Ben. In this video, I want to show you something from a study I've been thinking about since I first read it. Researchers at Massachusetts General Hospital followed nearly 3,000 adults for over 30 years, ages 42 to 94, up to 5 detailed health assessments per person between 1983 and 2017. What they found about breakfast timing, biological aging, and mortality risk is something that most people in their 60s have never heard, because until now, nobody thought to study this population. I'm going to explain the biology first, then show you the research, then give you the 3 practical steps. Stay with me. The third step is the one that will surprise you most. Let's start with a question. Do you know what time it is inside your body right now? Not the clock on the wall. Your body has its own clock. Actually, thousands of them. Every organ, every tissue, every cell runs on a roughly 24-hour biological cycle. Your heart, your liver, your kidneys, your brain. Each one has its own internal timing mechanism, coordinated by the same molecular clockwork. These clocks are orchestrated by a master timekeeper in the brain, a tiny cluster of neurons in the hypothalamus called the suprachiasmatic nucleus, or SCN. The SCN receives light signals from specialized cells in your retina. When morning light hits your eyes, the SCN fires, signaling to every peripheral clock in your body. It's daytime. Begin the morning program. What happens next is a cascade of precisely timed biological events. Cortisol surges within 30 to 60 minutes of waking, mobilizing energy and sharpening alertness. Insulin sensitivity peaks in the morning, meaning your cells are most receptive to glucose in the early hours. Digestive enzymes prepare. The gut microbiome shifts into its daytime configuration. Every system in your body orients toward the same opening act. And then you eat breakfast. When breakfast arrives in alignment with that morning program, cortisol high, insulin sensitivity strong, digestive systems primed, the body processes it efficiently. Blood sugar is handled smoothly. The peripheral clocks in your liver and gut receive a confirming signal. Yes, it is morning, the program is running. But here is what happens when breakfast is delayed 2, 3, or 4 hours after waking. Your cortisol has already peaked and begun to fall. Your morning insulin sensitivity window is closing. Your peripheral clocks, primed and waiting for the confirming signal of food, are still running in a kind of standby mode. And when that signal finally arrives 3 hours late, the system doesn't simply adjust. It runs misaligned. The liver's clock says one thing. The gut's clock says another. The brain's master clock, set by light, is already 3 hours ahead of where the body's feeding clock has placed morning. Researchers call this circadian misalignment. David's breakfast shift from 7 to 10 wasn't dramatic. It didn't feel like a health decision. But every morning, for months, he was sending every clock in his body the same message. Morning starts at 10 now. And his biology was responding accordingly. Now, why does this matter specifically after 60? Because after 60, the circadian system is already under pressure. The SCN loses neurons with age. The amplitude of cortisol rhythms flattens. Melatonin levels decline, disrupting the precision of the sleep-wake transition. Research published in Frontiers in Aging found that reduced rhythmicity of melatonin and cortisol in older adults is associated with higher risk of metabolic dysfunction. A review in Genes and Development noted that circadian disruption in aging is closely linked to cognitive decline, depression, and increased rates of Alzheimer's and Parkinson's disease. The circadian system after 60 is less resilient, more vulnerable to misalignment. And one of the most reliable misalignment signals it receives, 365 times a year, is the timing of the first meal. Now let me show you what the research found. The study I mentioned, published in Communications Medicine, a Nature journal, in September 2025, was led by Dr. Hassan Dashti, a nutrition scientist and circadian biologist at Massachusetts General Hospital. It analyzed 2,945 community-dwelling older adults with up to 5 repeated health assessments over a 34-year period. The findings came in 3 layers. First, as people age, breakfast naturally shifts later. This is not only about lifestyle or retirement. It correlates with genetic chronotype scores. There is a biological drift toward later timing with age, independent of behavior. The older adults in the study were eating their first meal progressively later over time, associated with genetic markers for evening chronotype. Second, later breakfast timing was significantly associated with higher multimorbidity, the presence of multiple chronic conditions simultaneously. The people eating breakfast latest were carrying the heaviest burden of physical and psychological illness. Third, and most striking, later breakfast timing was linked to increased all-cause mortality risk over the follow-up period. Our findings help fill that gap by showing that later meal timing, especially delayed breakfast, is tied to both health challenges and increased mortality risk in older adults, said Dr. Dashti. Now, the researchers were careful, and I want to be careful too. This is observational data. It does not prove that a late breakfast causes early death. The authors explicitly acknowledge that later breakfast timing may be a marker of underlying poor health, rather than an independent cause. People who are unwell tend to eat later. People experiencing depression tend to eat later. But here's what that doesn't change. It means the timing is a signal, measurable, visible, and modifiable, that tracks with everything we already know about circadian misalignment and aging. And it sits on top of experimental evidence, showing that when you deliberately misalign meals with circadian biology, biological aging markers worsen. A 2024 study in Food and Function found that delayed first mealtime was independently associated with accelerated biological aging using validated blood-based aging clocks. A 2026 study in NPJ Science of Food found delayed first meal specifically associated with liver and metabolic aging markers. Taken together, the picture is consistent. When breakfast comes late, the body's clocks fall out of step with each other, and in an aging body where synchronization is already eroding, that misalignment amplifies what's already happening. The mortality finding is preliminary and observational. What is established across experimental studies, not just observational ones, is that these timing patterns worsen the metabolic markers that predict long-term health outcomes. That's the piece worth acting on. David's story has a second chapter. About 6 months into his retirement, his daughter, a physician, visited for a week. She watched him move through his mornings. Sleep until 8:30. Coffee until 9:30. Breakfast around 10. Then spend the rest of the afternoon feeling sluggish, foggy, and slow in a way he'd started to accept as just getting older. She asked him one question. "What time did you eat breakfast when you were working?" 7, he said. "Why?" She told him what I'm telling you now. So, what are the 3 things the evidence actually supports doing? And I'll tell you where David landed on each one. The first is to eat breakfast within 90 minutes of waking. Not immediately. The cortisol awakening response takes 30 to 60 minutes to peak, and eating before that peak means eating against the metabolic tide. But within 90 minutes is the window where insulin sensitivity is highest, digestive readiness is strongest, and the peripheral clocks are most receptive to the synchronizing signal of food. David's daughter told him, 90 minutes from when you wake is the window. He set his alarm 30 minutes earlier and ate by 8. Not a dramatic change. A timing shift of 2 hours from where he drifted. The second is morning light before or with that first meal. The suprachiasmatic nucleus, the master clock, is set by light, not food. Food sets the peripheral clocks, the liver, gut, pancreas. Light sets the master. Both signals need to arrive in the morning window. 10 to 15 minutes of natural light within the first hour of waking, outside without sunglasses, weather permitting, is enough to sharpen the cortisol awakening response and anchor the SCN to true morning. This is not sunbathing. It's giving your master clock the calibration signal it uses to set every downstream rhythm in your body. David started walking to get the paper instead of having it delivered. 8 minutes outside, right after waking. That was the whole change. The third step is the one I said would surprise you, and it's the most counterintuitive of the 3. It has nothing to do with morning. Stop eating at least 2 to 3 hours before sleep. The Communications Medicine study found that dinner timing and the length of the daily eating window also shifted with age. Older adults in the study were eating closer to sleep over time. The research on this is consistent. Eating close to sleep suppresses the nighttime restoration programs that the body runs when it believes feeding is finished for the day, including the brain's waste clearance system, which flushes metabolic byproducts during deep sleep. Finishing dinner by 7 or 7:30 for someone going to bed at 10 closes the daily eating window in a way that lets those programs run completely. David moved dinner 30 minutes earlier. That was it. Finished by 7. In bed by 10. He didn't change what he ate at any meal. He changed the window those meals sat inside. He did all 3 things for 8 weeks. He told his daughter the afternoon fog had thinned. His sleep was deeper. He used this word specifically, synchronized, like the parts of his day were lining up in a way they hadn't since he'd stopped working. His daughter was careful not to over-attribute. One person's experience is not a clinical trial, but it was consistent with what the research predicts and with the mechanism she'd explained. He said something to her that I think captures what all of this points toward. I didn't realize retirement had taken away the thing that was keeping me on schedule. I thought I was finally free, but the schedule wasn't for my job, it was for my body. The body after 60 is not less capable of running its biological programs. It is more dependent on the cues that tell it when to run them. The timing of your first meal is one of the most powerful cues you give it every single day. Here's the specific conversation to initiate at your next appointment. Write this down. I'd like to check my fasting insulin and calculate my HOMA-IR, the insulin resistance index. And I'd like to discuss whether my current meal timing pattern may be working against my circadian biology. Given my age, are there any markers in my blood work that might improve with an earlier eating window? Fasting insulin with HOMA-IR is an orderable blood test that gives a far more complete picture of metabolic health than fasting glucose or A1C alone. It measures insulin resistance directly, the metabolic disruption that circadian misalignment is most consistently associated with. A physician who follows metabolic medicine or who is familiar with chrononutrition research will engage with this question immediately. And if your fasting insulin is elevated even with normal glucose, that is exactly the kind of early signal that an earlier eating window is specifically designed to address. In the next video, I want to bring something together that may reframe this entire series for you. We've now covered 3 systems: your medications, your gut, your body clock. Each one matters on its own. But there is a point where they interact, where a disrupted body clock makes the gut microbiome more vulnerable to the phase transition we discussed in video 2, and where that gut disruption amplifies the cognitive effects of the medications from video 1. These 3 systems don't run in parallel. They amplify each other. Understanding where they intersect changes what you address first. That's the next video. Subscribe so you don't miss it. And if you know someone who retired recently and noticed their energy and mental clarity shift without any obvious cause, share this with them. It might not be aging. It might be that the schedule changed and nobody told the body. I'm Dr. Ben. I'll see you in the next one. The information in this video is for educational purposes only and does not constitute medical advice. Always consult your doctor or a qualified healthcare professional before making changes to your diet, daily routine, or health management plan.